Hello students, and welcome to our lesson on rectangles as we continue Unit 8 on quadrilaterals. Our lesson objectives are two. We want to recognize and apply the properties of rectangles, and then we want to determine whether certain parallelograms are actually rectangles. The definition, hopefully you remember this from earlier in the unit, a rectangle is a parallelogram with four right angles. So it's that type of specific parallelogram. And based on this definition and the properties of parallelograms that we've learned, we know that it has the following five properties. First of all, all four angles are right angles, and again that's based on the definition as well as theorem 6.6 that we learned about parallelograms, which told us that if one angle is a right angle, then all four angles must be right angles. And we also talked about that in the Google form that you submitted. I asked you about that and I went over that in a previous video. Next, the opposite sides are parallel and congruent, and that comes from the definition of a parallelogram as well as theorem 6.3 on parallelograms. So the opposite sides must be parallel and congruent, and so we're going to mark that on our triangle here, that they're both parallel and congruent to each other. Third, we have opposite angles are congruent from theorem 6.4. For all parallelograms, this is true, and since a rectangle is a parallelogram, it's true for it as well. Now, because we have all the angles already marked as right angles, that implies congruency. And that's the same for this next one, that consecutive angles are supplementary from theorem 6.5. So we know that, for example, A and B, because they're consecutive, must be supplementary, and that's 90 plus 90 equals 180. B to C are supplementary, C to D would be supplementary, and D to A supplementary, since those are all consecutive angles. And then finally, diagonals in all parallelograms will end up bisecting each other. So, and remember, I mentioned this, I believe, in class, but these diagonals bisect each other. They're not necessarily angle bisectors. It's just that when they cross each other and you make the diagonals themselves get bisected. And we're going to be learning one more property in this lesson. So let's take a look at the theorems. We've got two of them for rectangles. Theorem 6.13, if a parallelogram is a rectangle, then its diagonals are congruent. So not only do the diagonals bisect each other, as in all parallelograms, but specifically for rectangles, the diagonals are going to be congruent to each other. So in abbreviated form, we write that if a parallelogram using the symbol is a rectangle, then the diagonals are congruent. There's the abbreviated form. And in terms of our specific example here, if JKLM is a rectangle, then we know that line segment JL must be congruent to segment MK. Okay? So JL, that entire diagonal, must be congruent to MK if we're talking about a rectangle. That is a specific theorem for rectangles, not for all parallelograms, only rectangles at this point. Okay, and then the converse of that, if you remember back to converses from earlier in the year, and I think I spoke about it in the last lesson as well. Remember, with a converse, you take a conditional and you flip the if and then, and that's really what we're doing here with theorem 6.14. This says, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if you didn't have the other information, like the measures of the angles to know that we're all four right angles, if you didn't have that information, but you knew the diagonals were congruent, then that would tell you that the parallelogram is a rectangle. That's how you could prove it. So again, in our example here, if WY is congruent to XZ in parallelogram WXYZ, then we can say that parallelogram WXYZ Y, Z is, sorry, this is really messy, a rectangle. And I'm going to abbreviate that because it's really hard for me to write with this right now. Okay, so what we would say is that WXYZ is a rectangle if we know that WY, that diagonal, is congruent to XZ. So the additional property of rectangles that we learned this lesson is that the diagonals of a rectangle are congruent. That's the end of this lesson. Watch the video on the practice problems. See you in class.